In this video, what we're going to look at is we're going to look at one of the final key aspects of working with our trig functions and equations that we need to know at higher level mathematics, and that's what's called the wave function. Now, think about waves in terms of your sine and your cosine graph. If you think about the way that they're drawn, sine and cosine are essentially a wave repeating over and over and over again. If we were to combine these two functions in some form, we would get a new wave that would repeat itself over and over and over again. What we're going to look at doing is taking this new wave and writing it in such a format that it can be expressed in terms of one of the other functions of waves. So what we're going to look at is quite simply taking something that's of this form here, a form p cos x plus q sin x, and representing it in one of the four forms that we see here. So we're going to represent it as either k cos x plus alpha, k sin x plus alpha, k cos x minus alpha, or k sin x minus alpha. Now, each of these four can be done using our double angle expansions that we've covered already. So expansions for cos of a plus b, cos a minus b, sin a plus b, and sin a minus b. So all that's going to come into play here. The only difference here is with two special key elements for each of these. One is the k. Now the value of k comes from taking the square root of p squared plus q squared, which are the coefficients up here. And alpha. Now alpha comes from the relationship tan alpha equals k sin alpha over k cos alpha. Now again, you're looking at this going, where have these come from? Well, the best way to illustrate this to you is working through an example and showing you where these parts all come from, how to calculate them, and the steps that are involved in calculating this sort of equation. So, imagine I give you the task, write 5 cos x plus 12 sin x in the form k cos x minus alpha. So there's a few key steps you would need to follow to be able to write that. First key step would be to focus on the form for the wave that they want you to do. They want me to do k cos x minus alpha, so what I should do at this point is to begin with is to expand it. So I want to expand k cos x minus alpha. So let's expand this using the double angle formula we know. We know that cos of a minus b is written as cos a cos b plus sin a sin b. So the same would be here. The only difference is instead of an a, I'd have x, and instead of a b, I'd have my alpha. But the other difference would be there's a coefficient of k here. So each term in my expansion would need a k coefficient. So I'd actually have k cos x cos alpha plus k sin x sin alpha. Now, look at the way this is written up here. The original function was 5 cos x plus 12 sin x. What to do is when you're writing this out, group together the coefficient parts of it. So the cos x is the function dependence, sin x is function dependence, so write it as k cos alpha cos x plus k sin alpha sin x, because that helps our next step. That helps the second thing that we should do. The second thing we really should do is compare this with the original function. So what I want to do is compare k cos alpha cos x plus k sin alpha sin x, and I want to compare that with 5 cos x plus 12 sin x. So if I look at these and I compare both terms, if I compare the first term, the k cos alpha cos x, if I compare that with the cos x term here, I've got a cos x and I've got a cos x, but I'm able to easily say that k cos alpha equals 5 from this. If I then do the same by comparing the sin x terms, well, my sin x is, they're the function part, we can ignore that, k sin alpha equals 12. So I've got k sin alpha equals 12 in this case. So what I now have is something for k cos alpha, and I've got something for k sin alpha. Now, if we think back to what we said a second ago, there were two things that we're now able to calculate, and that's our next step. The first is the k value, because we know that the k value we said was square root of p squared plus q squared. And remember, p and q were the coefficients of the cos and the sine. So P in this case is going to be the 5, and Q in this case is going to be the 12. So I know then that my K is equal to the square root of 5 squared plus 12 squared. 5 squared is 25, 12 squared is 144. What I'm then able to do is say it's the square root of 169, which is 13. So I know the value for K from my final equation. Excellent. The next thing I now need to figure out is what this alpha part is, but this is where the relationship tan alpha equals K sine alpha over K cos alpha comes into play. I know what K sine alpha is, it's 12. I know what K cos alpha is, it's 5. So it's going to equal 12 over 5. Now this is where a key trick has to come into play. Our value for alpha can be anywhere between 0 and 360 degrees. Now the issue with trig functions, if you think about them in their basic form between 0 and 360, they repeat. So sometimes you get multiple answers for this. What we have to do is find the quadrant in our cast diagram where all three of these functions exist, and that is where the answer we get is. So let's imagine we have our cast diagram here. Now remember, these letters tell you which is positive within each of the sections. So I know that between 0 and 90 degrees, all of them are positive. 90 and 180 sine is, 180 to 270 tan is, and 270 to 360 cos is. Now if we look at these values here for K cos alpha, K sine alpha, and K tan alpha, we know that K cos alpha is 5, so cos is positive. So I know if I was to just look at that one on its own, it would be those two. K sine alpha is 12, which is positive. If I just look at those ones, again, it would be positive, so it's in those sections. And I know tan alpha is positive as well, so tan alpha would exist in those. Well, there's only one quadrant where all three of them exist, and that's the A quadrant. So I know my answer for alpha is going to be between 0 and 90. So what I can safely say then is whatever I get when I take tan minus 1 of 12 over 5, that is going to be my answer that I'm going to get and I'm going to take for alpha. Had it been any of the other ones, I'd have used this answer and the relationship I know in each of these sections to find the answer I'm after. So alpha is tan minus 1 of 12 over 5, which in this case gives me 67.4 degrees to 1 decimal place. So now I have the alpha part, now I have the K part, I'm able to write this whole thing out, and that is the final step. You have to combine everything together to get it in that final form. So at this point, I now say 5 cos x plus 12 sin x equals, well I know it's going to be K cos x minus alpha. K is 13, so it's going to be 13 cos of bracket x. Take away the alpha, which in this case is minus 67.4 degrees. That's me rewritten this function in this form here. So I've rewritten this wave using that expanded bracket form. When we're doing a question like this, it doesn't matter which version of our waves it asks us for. It doesn't matter if it's K cos x minus alpha, K cos x plus alpha, K sin x minus alpha, or K sin x plus alpha. If we follow these steps every single time, we'll nail it. First thing, expand it. Get your coefficient terms together, your K cos alpha, K sin alpha. Once you've done that, equate the two functions. Equate your original with your expanded form and get your K cos alpha, K sin alphas. From there, use the fact that K equals the square root of P squared plus Q squared, so your two terms here, to get your value for K, the coefficient of the overall wave. Then, use tan alpha equals K sin alpha or K cos alpha to get your angle alpha. Remember to use your cast diagram and you're looking for the area where all three of them can exist at the same time. So the area where maybe all three of them are positive, where certain ones are negative, whatever one has the three ticks, that is the quadrant you take your angle in. Just remember back to in S4 when we did solving equations at this point, how we find the angles in each section. So you get the angle here from just solving it naturally. This one here gives you 180 take away the angle, 180 plus the angle, and 360 take away the angle. If you need a recap on this, go back and look at the solving trig equations video. Once we've got that, we find our angle and we substitute it all in. You're not done until you have put everything together in that final step. Do not finish the question until you've done that. You'll cost yourself marks, and with the work you've put in up to this point in this type of question, that's not something we're looking to do.